Hello students, today we will discuss Cambridge A-Level Physics paper 11 May 2022. Teaching back with Nariman Zakuliyev, email ernariman@hotmail.com. This is the cover page. Exam took place in May-June 2022. It is the first exam according to new syllabus of 2020. Data, some formulas. Question 1. Which term represents a physical quantity? Spring constant is force divided by extension, so it is physical quantity. Meter is unit. Percentage uncertainty is uncertainty in the measured value. Quark flavor is collection of quarks. So answer here is D. Question 2. Which two units are identical when expressed in terms of SI base units? So you should work hard and the answer is B. So here you should know that joule is kilogram meter squared over second squared multiplied by second. Question 3. A value for acceleration of free fall on Earth is given as 10 plus minus 2. So the value is inside this uncertainty range, but uncertainty is too big, so we choose answer A. The value is accurate but not precise. Here we see two forces acting on bracket. You should resolve each force into horizontal and vertical components and add them or subtract if they are opposite. So after calculations, including trigonometry, we are getting answer C. Attention, for vertical resultant force, you need to subtract forces because they are opposite. For horizontal, you should add components because they are in the same direction. The curved line PQR is the velocity time graph for a car starting from rest. What is the average acceleration of the car over the first 5 seconds? Average acceleration is change of velocity by time taken, so it is exactly gradient of the tangent at Q. No, sorry, the gradient of the straight line PQ. A ball is thrown horizontally with speed 10 meters per second above horizontal ground. The ball hits the ground after time of 3 seconds. Here resistance is negligible. What is the speed of the ball just before it hits the ground? So I have drawn vectors here. The horizontal component doesn't change, but vertical component is increasing with time. And after 3 seconds, it is 29:45. Using Pythagorean theorem, we find the resultant speed. Answer is C. An object is moving along the ground in a straight line at a constant speed. Which statement about resultant force acting on the object is correct? Of course, resultant force acting on object is equal to 0. Water flows out of pipe and hits a wall. When the jet of water hits the wall, it has has horizontal velocity v and cross-sectional area a. The density of water is rho. The water doesn't rebound from the wall. What is force exerted on the wall by the water? Because water doesn't rebound, mass multiplied by velocity over time period will be the force. In 1 second, volume is VA, mass is rho VA, change of momentum in 1 second is mv or rho v squared a. Answer is D, but you can solve this also using base units. Base units of for answer D is kilogram meter minus second minus 2. A projectile is launched at an angle above horizontal ground and travels through the air. The projectile reaches its maximum height at point X. Assume that no obthrust acts on the projectile. Which diagram shows the direction of the force or forces acting on the projectile at position X? Because it is still moving, air resistance is acting against the motion. So it is moving horizontally, air resistance is acting backwards. Also weight is always present, so we choose answer B. What is the statement of principle of conservation of momentum? This you should learn by heart. The total momentum of a system of interacting object remains constant, providing no resultant external force acts on the system. Horizontal wooden plank is pivoted at one end as shown. The plank has a mass of 100 kg and a length of 10 meters. The center of gravity of the plank is a distance of 4 meters from the pivot. What is the moment of the weight of the plank about the pivot? Weight is acting on the center of gravity. Weight is 10 to the third. We multiply distance by force, by weight. We get 4 10 to the third. C. Answer C. When must an object be in equilibrium? When no resultant forces and no resultant torque act on the object. This is a choice. A uniform diving board is held by two fixed rods at position points P and Q. A person stands at the end R of the diving board as shown. I have drawn here additional arrows to represent forces. The forces exerted by the rod on the board are vertical. The board remains in equilibrium as the person slowly moves towards point Q from end R. Which row describes the change to the magnitude of the forces exerted by the rods on the board? As the person moves towards the rods, moment of force decreases. So anti-clockwise moment decreases. No, clockwise moment decreases. As clockwise moment decreases, anti-clockwise moment also decreases, and these two forces are balanced by force acting on the Q, so Q also decreases. So answer A. A solid block has sides of length L to L and 4L. The block is submerged in water of uniform density so that the faces with the largest area are horizontal as shown. The obstruct acting on the block is U. The block is now rotated to a new position so that the bases with smallest area are horizontal. The block remains fully submerged in the water. What is the upthrust acting on the block? Upthrust equal weight of displaced water, so no change because all block is submerged. Volume of displaced water is the same and weight of this water is the same. 15. In a large container in an oil refinery, three oils of different density are mixed. No chemical activity occurs. The mixture consists of three types of oils. What is the density of the mixture? So, density is total mass by total volume. First we find volume of each oil, then we find total, then we find density dividing total mass by total volume, and we get choice A. Question 16. A box slides down a rough ramp. The change in its gravitational potential energy of the box is 16 as it moves between positions x and y. The box has 24 joule of kinetic energy at x and 35 joule of kinetic energy at y. So change of potential energy is minus 16. Change of kinetic energy is 11. As a result, we see that 5 joules of energy dissipated as heat probably. How much work is done against the frictional force? Choice A, 5 joule. The total energy supplied to an electric motor is E. Energy Q is wasted and the remaining energy does useful work. What is the efficiency of the motor? Efficiency is useful energy by total energy. Useful is total minus wasted. If we call total E, wasted Q, then we get choice C. Objects with different masses are placed on the horizontal surface of a table. The objects are then raised to different heights above the table. The gain in gravitational potential of each object is the same. Which graph best shows the variation of height of the object above the table with their mass m? So change of potential energy is mgh, more mass, less height. So inverse proportion. Inverse proportion is A. Two wires P and Q are made from the same metal and hang vertically from a steel girder. Wire Q has the half length and twice the diameter of wire P. Identical masses are attached to the bottom of each wire. Both wires obey Hooke's law as they are stretched by the weight of the mass. So wire P. So for point P we have this extension, and for point Q we have to decrease area by 4 and increase length by 2, so 8 times less extension. This formula for extension comes from Young modulus, actually. Which statement about elastic and plastic deformation must be correct? The last one, elastic deformation is reversible, but plastic deformation is not. The graph shows the variation with time of the displacement of a particle as the progressive wave passes. What are the frequency and the amplitude of the wave? I have drawn here period. Period is 10 seconds because not second, nanosecond. And as a result, frequency is 1 over t is 100 megahertz. Frequency is 100 megahertz and amplitude is 5 from middle position to maximum displacement. The graph shows the variation of displacement of an air particle with time as the sound wave passes through it. Again, we have displacement and time. The intensity of sound is halved while the frequency remains constant. Intensity is half means divided by 2, then amplitude is divided by square root of 2 because intensity is proportional to square of amplitude. The four graphs below are drawn to the same scale as the graph above, which graph shows displacement of the air. Frequency remains constant. So constant frequency we have C and D. But change of amplitude is correct in D. It is not 2 times, it is square root of 2 times. Which statement is correct? Solids can transmit both transverse and longitudinal waves. That's correct statement. A car is traveling at constant velocity directly towards a man standing in the middle of the road. The driver sounds the car horn as warning. The horn emits a sound wave of constant frequency. The frequency of the sound heard by the man is different from the frequency of the sound emitted by horn. Which statement is correct? The wavelength of the sound heard by the man is less. They are approaching less than the wavelength of the sound emitted by the horn. So if you know our universe is expanding and wavelength is increasing. Here we have approaching objects, wavelength should decrease. Which statement about electromagnetic waves is correct? You can answer this question by elimination. They cannot be polarized. No. They consist of vibrating atoms. No. They move through vacuum. They can all travel at different speed in free space. No, they travel at the same speed of light. Now, if we convert meters into nanometers, we see that this is invisible for us. We can see only from 400 to 700 nanometer. A stationary wave is set up on a string that is stretched between two fixed points that are 48 centimeters apart. At one instant, the appearance of the string is shown. What is the wavelength of the stationary wave? So, wavelength is node to node distance, half of wavelength. So node to node distance is half of wavelength, and it is equal to, if we divide by 3, 16 meters, then lambda itself will be 2 times more, 32 centimeters. A pipe closed at one end and has a loudspeaker at the open end. For some frequency of sound from the loudspeaker, a stationary sound wave is formed in the air within the pipe with an antinode at the open end. So loudspeaker is at the open end, and here we have maximum antinode. Antinode. Question 27. A pipe closed at one end has the loudspeaker at the open end. For each some frequencies of sound from the loudspeaker, stationary sound wave formed in the air with the pipe with an antinode at the open end of the pipe. The length of the pipe is so much, the speed of the sound is so much. What frequency of sound from loudspeaker would not produce a stationary wave? Here it is better to remember the formula for pipe closed with one end. It is frequency equals 2n minus 1 v over 4 lambda for L. L is length. So we see that the number should be odd number multiplied by 100. So only B is not odd number. Water waves of wavelength lambda are incident normally at a distance with a narrow gap. The width of a gap is equal to lambda. The waves from the emerge over angle theta. The gap is slowly widened, which changes, if any, occur to theta, and wavelength of the emerging waves. Theta decrease and wavelength remain the same. Light of single frequency passes through two narrow slits and produces an interference pattern on screen some distance away. The interference fringes are very close, which change would increase the distance between fringes. So you have formula. Distance between fringes equals wavelength distance to screen and divided by distance between slits. So answer choice B increases the distance between so you should make distance between the slit and the screen larger. Light of length so much is normally incident normally on a diffracting grating. The separation between adjacent lines is so much. The light that emerges from the grating falls on a semicircular screen as shown in the in the view from above. Here we use formula and lambda equals d sine theta and we take extreme value 90, so sine will be 1. As a result we get 3. So 3 above, 3 below and 1 central makes 7. A straight copper wire of diameter so much has a number of density of free electrons of so much. In a given line in time interval, a charge of moves through the wire. What is the average displacement of free electrons along the way in this time interval? So distance moved by free electrons is the drift velocity multiplied by time. Time can be found from charge divided by current. For current we have special formula with number density. So as a result we get choice C. So if we calculate, V disappears, all the rest we know. What is the definition of potential difference across a component? V is okay, the voltage across the component, but B gives more information, energy transferred to the component per unit charge. The graph shows the IV characteristic of semiconductor diode. Which statement can be deduced from the graph? Of course, resistance of the diode depends upon the potential difference across it. A wire has resistance 30 ohm. A second wire is made from the same material, has the same mass, and is 3 times as long as the first wire. What is the resistance of the second wire? Same mass means same volume, and volume is length multiplied by area. Length increases 3 times, area decreases 3 times. As a result, resistance increases 9 times. Here you can recall formula R equals rho LA. A cell has internal resistance R, electromotive force E. The cell is connected in series with an ammeter and variable resistor. When R is 10 ohm, the ammeter reads 0.3 amperes. When R is 5 ohm, the ammeter reads 2.4 ampere. What is the value of E? So we have this formula and we have values for two cases. Solving the system, we find R and then E, and answer is D, 6 volt. The sum of current entering a junction in an electric circuit is always equal to the sum of currents leaving the junction. Why is this? It is a consequence of conservation of charge. In the circuit shown, the temperature remains constant. In which circuit does the potential difference increases with increasing light intensity? So we need light-dependent resistor, and voltage increases this voltage increases because light-dependent resistance drops and more voltage falls on thermistor, so increases D. Carbon-14 decays into nitrogen-14 by emitting a beta minus particle. It means that one neutron turns into proton. Which statements explain why the beta minus particles are emitted with a range of different kinetic energy? The reason is that the third particle is involved and it is antineutrino. The energy released in the decay process is shared between the nitrogen nucleus, a beta minus particle, and an antineutrino. 39. A nucleus of radioactive element emits an alpha particle, then beta minus particle, and then another beta minus particle. So when it lost alpha particle, it lost 2 protons. During beta minus process, it gained again 2 protons back. So the same number of protons. Which statement describes the final result that is produced? It is isotope of the original element, because isotope has the same number of protons but different number of neutrons. How many hadrons, baryons, and mesons are there in a nucleus of beryllium? So beryllium, 9 baryons, there are at the same time hadrons, and no mesons because no antiquark. Here we finish our discussion. See you later. Bye.